All right, so let's get started. 11:30. I don't know how many people logging online, but I think yesterday, today I'm going to start with talking a bit about the exam instead of at the end, in case we run a bit out of time. So let's see. You have exam Thursday, no? Okay. Yeah. So I just want to let you know, we are doing good with materials. I might not be here. I'm trying to change it, but I just found out that I might not be here Monday because I need to go to the consulate. Okay, so I don't know. I'm thinking about either to give you the free time to work maybe on the project on Monday, or to move the exam on Monday, but then I have to find somebody to proctor. So far, let's leave it as on Thursday, okay? It's probably gonna be Thursday. So I think we decided that we're gonna have two problems, no? So one problem probably would be like some type of wing spar. So I don't remember which problem we did in class, but I think wing spar generally are like whatever. This geometry, no, or they might even be symmetric, no, I don't know. Yeah, that would help, I guess. So these type of geometries, no? Okay. I don't know, wing spar can be this geometry, but I think where I can maybe complicate it a little bit more. And the exam, I'm going to make it open notes. No assignment, but open notes. Okay, so that way there's no problem of equations and so on. But probably what I'm going to do is to change whatever can be the loading on top. So I think right now we just apply a load in here, P, no? Okay, I might make it a little bit more complicated. So let's say I can make whatever. Let's say I can make either, yeah, probably make something like this, not the other one. Okay, let's say I can either make a distributed load now. Yeah, but that one is not that realistic. I mean, I'm not saying it's not realistic, but generally, yeah, that's generally the load you have on a wing, no? Yeah, sorry, I should have. This type triangular, no? Yeah, I'm pretty sure you have done that one many times, no? So in that case, you might have a little bit more difficulty to find the moments, no, at a certain location. So maybe I put this, and I don't know, something like this. We probably put this, and then maybe I add the force over here, or maybe a force somewhere else. But basically, practice to find out the bending moment, no, of a beam subjected to maybe a distributed load, not only the load at the end. Is that okay? Yeah, the rest should be straightforward. No, once you have the moment, and the shear force should not be that difficult. Problem 2. I don't want to give things that you need those MATLAB codes. So problem number 2. I think we have done this one, so at least one of them, if I remember right in class. The ones of the wing box. Oops, all right, so I don't know what's going on here. Okay, remember the ones of the wing box over here, where this is clamp and basically go and remove one panel. Yeah, so I think we have done removing the top panel or the lower panel, is that correct? All right, so what about you practice? Because that's probably what I would do. Okay, I will remove a panel that we haven't done in class, no? So what would be the panels that I can remove that we haven't done? Maybe I can remove this side panel, no? Yeah, and this would be a load. So imagine would be either load up or in that direction, but the shear is not a problem, and a torque, no? The torque is the one that creates a problem. So practice this type of problems, like this type of problem where I remove either the top or the bottom panel or the first cell or the second cell, and practice one where I remove the side panels or the first cell or the second cell, no? Yep. This one. This one. This one. This one here. No, I don't think so. Okay. So if you want practice all the other options, okay. But I mean, you can prepare for the exam, no? You know what's going to be on the exam. Okay, here I don't have the options. I mean, I think we remove this panel and this panel, no, on the class note. So I'm going to remove one of the side panels. So practice this one or this one, or but also practice what we have done in class. Okay, and you can practice, and you can go to FIMAP, and basically will tell you if you are doing it wrong or right. No. Yeah. So study in a smart way. Any question about the exam? Clear how to prepare? No? Yes.
For main spar or anything like that, something like the reasoning for like method 1, method 2.
No. Wings part, this is 2D. Basically, this is the one where you have case 1 where you can find that the shear is either uniform, okay, or you remember it will be this way, no, for case 1 or case 2. No, it's tough. Look at the notes. This is the first ones that we did for wing spar, not the one that had the not 3D, it was 2D this part. Okay. You have 2 cases. I give you the choice to, yeah, it is. I will probably say case 1 or case 2, depending. I mean, I probably was. I'm not going to promise this stuff, but probably I do case 1. You know. Okay. Yes. The other one is you need to do an integration. All right. Does that make sense? All right. So no questions from the people online. All right, so here we go. So we have been working on basically energy methods, no? So yesterday we did a problem that was about a truss that was basically looking at the strain energy due to the axial load that we had P squared over EA, no? Okay, integral of P squared over EA, okay? So today we're going to look at a different problem. And guys, these problems, I'm not going to say they're difficult, but it's easy to do mistakes because it's a lot of work to do. So in this one, let's say we have an L beam. That is clamped at this edge and simply supported at this edge. So this is 1, 2, and 3. And let's say this is subjected here to a load. Okay, I have here P bar. Don't ask me why, but P bar. And this is length L. So we can put values later on, but for now, let's leave it symbolic. So anyone has a problem picturing this? No? An L beam clamp over here simply supported over, no? So first question, is this problem statically or okay? So the question here will be determine the horizontal deformation at point 2. Okay, so at least we know what we need to do. So now, first question. Is this problem statically determined or statically indeterminate? Determined or indeterminate, you said? Okay, so what is the definition, Jali? Is that it is statically determined if you can find the reaction just from the equilibrium equations, no? Okay, so if you do, maybe let's do, okay, leave over here one space and say what would be always step one is always to do what? Free body diagram, correct. So free body diagram. So if you do the free body diagram of this one simplified, let's see, what will be the number of reactions? What will be the reactions at one? So let's say it would be R1X, this would be R1Y, no? What about at point 3? How many reactions do you have at point 3? Yes, R3Y, R3X, and a bending momentum 3. So how many unknowns do we have at the reaction? Just a matter to count, no? How many you have? 5. How many equations of motion can you get? How many equations of equilibrium can you get into the problem? 3. So then this problem is what? Indeterminate, okay? So if it's statically indeterminate, that means that we're going to need some additional equations now in order to solve, and these additional equations will come from where? What, Johnny, we have to look at? At the method of Jones, no? At the deformations, no? See what will happen with some type of deformations. Either angle of rotations or rotates. Okay, so let's over here. Okay, so yeah, so let's write down the equations. We're gonna say, all right, and see what happened over here. So if we write down the equations, what do we have? I mean, it doesn't matter which order we use, so it's not a big deal. So let's first do the summation of forces. So step 2. Let's say here Newton's equations. Really, this step is not needed to solve the problem, but I want to follow a straightforward procedure, okay? That everything is solved. So first thing, Johnny, will be to do what? Summation of forces on the x equal to 0. So this will give you what? P bar plus R1x plus R3x equal to 0. This will be our first equation. So second equation will be summation of forces on the y equal to 0. This one will give you what? R3y plus R1y equal to 0. This will be your equation 2. And finally, let's say we take moments about point 3. Don't take y as positive. I always follow the normal sign convention, the traditional sign conventions. So this will give you what? So let's say we'll give you minus
P bar.
Minus P bar times L, no? Then we can look at what? R1x. R1x will give you what? Also negative, no? Minus R1x times L. What about R1y? R1y, L positive, no? And are we missing anything? P, okay, and M3, no? Plus M3 equal to 0. So over here, okay, we already did it before, but basically what do we have? Three equations, 5 unknowns. This is the definition of what? Statically indeterminate. Okay, so I go to the next page. But what should be really step 3 in your head? To find the additional equations. Okay. All right. So if you look at this structure, do we know the deformation at a point or at some points? Do we know the deformations? First, how many additional equations do we need? 2. Okay. So do we know the deformations at a point over here? Which point?
3.
Okay, 3. But here will be at which other point? 1. Okay, so let's say we do 1. Okay, you could do 3, but since I have the results for 1, we're going to do 1. So at 1, what do you know? It will be the vertical deformation will be 0, and the horizontal deformation will be 0. No, is that 2 equations? Okay, so step 3, we know that let's say vertical deformation at 1 is 0. So mathematically, I'm going to write this one Q1 vertical equal to 0. That will be our equation 4. And what will be the other equation? Horizontal deformation at 1 is 0, or Q1H will be 0. Okay, so now what do we have? 5 equation, 5 unknowns. That is good, no? Okay, the bad thing is that how do we find the deformation? What did we do yesterday? Remember the Castigliano theorem, no? All right, so what we need to do is first, let's look at this one over here. What type of deformation is this bar going to have? So let's say this is 2 beams, okay? Beam 1, 2, and 2, 3. All right. So 1, 2 should be subjected to what type of stresses? Compression, so will be axial, no? Yes. So we could say that here you could have then, if we look at the strain energy, of our system, we'll have some strain energy due to axial that we say was equal to P squared over EA, whatever, I call it DX, but it could be DS, okay, but it could be DY as well. So this would be axial deformation, no? Yeah, bending deformation in 1, 2. So let's say this will be axial, basically, mostly will come from 1, 2. Now, if we look at the beam 2, 3, that one will be subjected to what? What type of motion will 2, 3 have? That's it. Bending, no? Correct? Yeah, it will bend, no? Due to the force. So that means now that we also need to consider what type of energy? The one due to bending. So what is the expression for bending? Integral of 1/2 m squared over EI. I mean, let me put here ds instead of dx because it will be a little more clear. Yes. So this will be axial, let's say, and this will be bending. Okay? Now, the deformation will be obtained using what? What did we use yesterday? Castigliano's, no? What did Castigliano say? That we said that Castigliano, the deformation at one point is equal to the partial derivative of the strength energy with a force that needs to be applied at that location as well. Okay? So in the present case, we know the strength energy is going to be in function of P, which is the axial force, and M bending moment. So you want to put here P axial force, M is bending moment. Okay, we need to find the what that horizontal deformation. Okay, so this deformation, no? So we need to have a force on the horizontal direction being applied at the point where you need to find the deformation, no? Okay, so in our case, we're trying to find what? Q sub 2 is equal to partial U divided by Q sub 2. Do we have a force acting at point 2 in the horizontal direction? Yes, so in this case, we could say that this would be equal to partial U, partial P bar, no? Okay, but on the example yesterday, we did not have a force being applied at a point where we needed to find the deformation. So what did we do? We apply a dummy force, no? So what happened here, let's say, if the force was here in the middle, you needed to apply a dummy force over there, no? Okay, in this case, yesterday the problem was statically determined with the dummy force. Today is going to be statically indeterminate, but not with the dummy force, no? Okay, but you could have both of them on the same problem. All right, so basically, what do we need to do now? We need to find the axial forces on the beams 1, 2, and 2, 3, and we need to find the bending moments in beams 1, 2, and 2, 3, no? Yep, in order to be able to solve. So let's go ahead and do it. So we're gonna here, next thing we're gonna do is we're gonna determine or find the axial forces P and bending moments in the beam. So how do you find the shear force and the bending moment? What do you need to do to the structure? Bending moment and shear force are what? Internal or external? Internal. So what do you do for the internal to become external? You need to make a cut. So you need to start from one end. So here for simplicity, we're going to start from point 1. All right. So let's say I'm here at point 1. I'm here at point 1, okay? I make the cut, no? You need to start from one end. All right. So I make the cut over here. Here we have R1Y, R1X. Here we're gonna have P1 will be the actual force, and this will be M1. Okay, so basically what we have done is what? We start from point 1, we made a cut here, no? Yeah? Okay? Okay, so let's say that this distance is upper S, let's say I want to go, we're going to move from this point over here, and let's say this is S, okay? That's why I wanted to call this S over here on this equation. Okay, so in order to find P1, what do we do? So measure of forces on the S1, let's call this one S1, so we're going to have an S2, will be equal to 0, so this will give you what? P1 minus R1x equal to 0. So that means that P1, the actual force will be equal to R1x. Okay, what do we do in order to find M1? We take moments about which point? What is, you always take the moments about the cut. No, when you do cuts. I mean, you can take it from the other point, but then it becomes a lot more complicated. So what would you get if you take the moments about the cut? You're gonna get, okay, I started with M1, so but yeah, so you will get then minus M1, and what is created the moment? The R1Y, no? So let's say R1Y times S1, will that moment be positive or negative? Positive, correct, so equal to 0. So this will just give you that then M1 is equal to what? R1 Y times S1. All right. All right, now. Okay, so we are here. You need to make a cut every time this is discontinuity on the loading. So we're going to go here. Now we're going to make a cut somewhere between 2 and 3. All right, so let's do that. So let's see, I go from one here to a point where I make the cut. So let's see, here we have R1Y, R1X, P bar. This is our cut. We're gonna have P2 and M2, same as before, no? Okay, 1, 2, this will be L. And now let's say this will be here the distance S2. Okay, so what do we do in order to find P2? Summation of forces on the S2. Okay, this will give what? R1Y minus P2 equal to 0, or P2, which is the actual force, would be equal to what? R1Y. Okay, and to find M2, summation of moments about the cut. So what do we get? What is critical moment? What about the force piece? Force P critical moment about the cut?
Yes.
Okay, that would be what? P bar times what? S2 would be positive or negative? Negative. What else? What about the force R1X and R1Y? Let's start R1Y. Is that one positive or negative? Positive. And what is the arm? L. Yeah, correct. And then R1X would be times S2 equal to 0, no? So you see, all this stuff is statics, no? Most of the problem. So from here, we can solve for, what are we trying to solve over here for? M2, perfect. So M2 will be equal to, so I can combine maybe these two terms. We have minus P bar plus R1X S2 plus R1YL. Okay, so let's do a little summary like yesterday, but this one it would be shorter. So let's say we're gonna have here our, segment or beam. So 1, 2, 2, 3. Our actual force P. So what do we have for 1, 2? One was R1X, no? And let's say here bending moment. What do we have for bending moment? R1Y as well. Okay. What do we have for the segment 2? We have R1Y is right here on top. And this one will be minus P bar plus R1X S2 plus R1YL. Okay, so why do we need this stuff? Why do we need it? In order to be able to solve for the deformations, no? From this equation. So now if I simplify, so let's say, so now let's recall the two additional equations that we had. What is that page? 1, 2. Step 3. Okay, our additional equations were what? Equation 4, Q1 vertical equal to 0. So let's say here. All right, so let's say here recalling the two additional conditions slash equation, which is what? Q1 vertical equal to 0 and Q1 horizontal equal to 0. These were equation 4 and 5. Okay. Okay, so I'm gonna go to the next page. We're gonna start by Q1 vertical. So Q1 vertical equal to 0. All right, then what do we have? Q1 vertical will be equal to differentiation of the strain energy. Okay, and now what do we need? In order to find the vertical deformation, we need to have a vertical force acting at that point, no? What is the vertical force acting at point 1? Oh, sorry, the vertical force, which one is it? The R1Y, no? Yes? Okay. So that means here we will take the derivative with respect to what? R1Y. Because it's the force on the vertical direction. Remember, in order to find the deformation, this is like force, like work. Work is force times deformation, no? If you think about it, so if you want to find the work in one direction, you need to have one force applied in the same direction as the force, no? Okay, same idea. Okay, so now here we go. So the general expression then will become what? So we look first at the, if we take the derivative of the strain energy due to the strain or to the actual force, we get the expression P sub I over EA partial P sub I partial of what? R1Y ds. This is the same thing as we did yesterday, plus the integral of the M sub I over EI partial of the MI sub I partial of R1Y ds. Okay, so over here, I'm going to do it slow, okay, so it's the first time. So this equation really, what should we have over here? We should have two terms for the actual terms. We have P1 over EA partial P1 over partial R1Y ds1 plus partial P2 over EA partial P2 over partial R1Y. This will be the actual deformation of 1 and 2, no? Then we do the bending plus integral of M1 over EI partial M1 partial R1Y ds. Oops, here I forgot the ds2 here, sorry, ds2, ds1 plus partial of M2 over EI partial M2 partial R1Y ds2. Okay. I mean, here is when it's useful to use MATLAB or something else. So let's look at our summary. What is our summary? Okay. So let's see. What is this? P1, no? What is P1 equal to? R1X, correct? So what would be partial of P1 with respect to R1Y? What would that be? P1 is R1X. If you differentiate R1X by R1Y, what do you get? 0. Good thing, no? What about M1? M1 we know is R1 R1Y times S1. So that one will be equal to what then? We have S1, it should be bending, yeah, should be S1, no? Okay. So which one are we doing here? We are doing the bending moment, no? Okay. Oops, sorry guys, I did it on the wrong place here. It should have been done here. So this is the 0. This one, eliminate this one. Okay. So, I mean, let's do now this one first. Sorry, let's do one by one. So, what is P2? P2 is R1Y, no? Yes. So, what would be the relative of R1Y with respect to R11? 1. Okay. Now we do the M1, which is the one we just did. This one should be equal to what? You just said before. What should be this term? M1 is R1Y times S1. What should be that term? S1, no? Yeah. And finally, what is M2? So that one is going to be a bit more complicated. M2 in function of, or not, M2 in function of R11 will be equal to what? L. Okay, so if I cannot rewrite this using everything, but again, best thing is to use Maple for this, okay, or MATLAB, whatever you want. So first thing is 0, so this will give us what? Q1 vertical will be equal to what? Integral of P2, what was P2? Is R1Y. Okay, P2 is, this one is 0, so I'm doing P2 R1Y divided by EA. Now this is 1, no? DS2. DS2 is going to vary between what and what? The length of that beam is 0 to L, no? All right. Now, hopefully, I'm not going to be able to put everything on the same line, but now we're going to look at what? At M1. What is M1 equal to? R1Y S1 divided by EI times S1 DS1, and we integrate this between what and what? 0 to L. Okay, finally, we're gonna have the M2. Again, this one is again between 0 and L, but what is M2? M2 is a long one over here, which is minus P bar plus R1X times S2 plus R1YL. All this stuff times what? L DS2. Yes, I forgot to put the EI here. Over EI, correct. All right, so I mean, this one is not that bad. You could almost just do it by, by hand, okay? But when stuff gets a little bit more complicated, is not fun at all, okay? So let's say you have access to software. So let's say I'm going to use over here. I mean, you can use either one. Let me go to Maple instead of MATLAB, or which one you want to use, MATLAB or Maple? I don't care, really. The only thing is that MATLAB, I like more MATLAB to do more stuff, but I think it's easier to see the output on Maple than MATLAB. Okay, that's the only reason why I like this one here for classes. Okay, so here, let's say blah, blah, blah. So I don't know how many I'm going to need of this, but it doesn't matter. So restart. I don't know what is the best way to do this. Okay, I'm doing this, you see, like with you. So what could be the best way to do this? All right, maybe it is that way. Let's see what would be P1. Let's try to put P1. What is P1? We say P1 is equal to R1X. P2 is equal to R1Y times S1. Yes. We can use MATLAB, yeah, no problem. But it's not going to look that pretty once you get it out, okay?
Never.
It's fine. The only thing, okay, I'm gonna tell you what is the only reason that I like it, okay? Is that we don't have to, we're gonna switch to MATLAB, but if you write, you see the letter beta, he writes the letter beta. You put gamma, he's gonna put the letter gamma. So if you have equations, you know, like alpha, gamma, MATLAB is not able to show it symbolic. Okay, but since this one, maybe it is not symbolic. I don't care. Let's get out of here, okay? And let's use MATLAB. I don't care. The only thing is that don't expect the output to look that good, no? In this case, I don't think it's a big deal. So let's switch to MATLAB. Okay, so I don't know why it's showing it that way to me. I hate this stuff, but so how can I remove this one? Can I just drag it over? I think I do. Oh, all right, good. Okay, so let's close this one for now, and let's see if I can put here this there. Okay, if I can do that. All right, so let me eliminate all this stuff here. New script. File, save as. I don't know where I need to save it, but summer 2023. So we have this one. Let's say what LBM. Okay, problem. That's it. Save. All right. So basically, I always do the same thing. Clear all. CLC. Let's put here LBM. Problem. So I might add some stuff at the front, but for now, let's say P1. So let's see. We're gonna have a bunch of symbolics here. So symbolics P1, P2, M1, M2, R1X, R1Y. Oops, I'll put I, stop one. One, then what should we have? I mean, we might need them. I don't think we need more than this. Okay. Then what are we gonna have? P1 is equal to what? P1 equal when I look here is R1X. P2 is equal to it's over here on the page. I keep looking around. R1Y times S1, so we need to define also S1 as a symbolic, S1, S2. Here. What did I do bad here? It's only R1Y?
Yeah.
Okay, thank you. So R1Y, yeah, that makes sense. Therefore, this should be equal to a force. Then we have here M1. That's the one which is R1Y times S1, and M2 is what? Is minus
Oh no, I'm looking at another page. So it's, yeah, but it's still that minus P bar plus R1X times S2 plus R1Y times L. I'm planning to add here L and P bar as symbolic. Okay, so hopefully nothing wrong so far. No, it's not showing anything wrong. All right, I forgot to close this one. All right, so now we go here, let's say, additional equation 1, which is Q1 vertical equal to 0, okay, equal to 0. All right, so what do we have over here? So the equation we just wrote, which is where? Right here. So how can we do this one? Okay, so Q1 vertical will be equal to what? To integral of, help me over here, of P1 over E over A. So symbolics A over EA times derivative, so differentiate P1 with respect to R1Y, correct? And now, how do you put the limits of integration of the integral?
First have to do there's one. It's comma S1 for the variable you want to differentiate or integrate.
Yeah.
To then comma
Okay,
0,
0, comma 12, perfect. Thank you. All right, so let's run it just in case to see if we get any issue. If it's not issue, it's perfect. Okay, so no issue, so good. So good. So basically now, what can we do? We can almost just do copy paste. So because we have the same thing for the second one, no? P2, partial P2. Let's see if that will work. I'm not sure that will work here, but 1, 2, 3, go to the line. If you want, we can almost do this copy paste, but now what do we need to do? The same thing for the moments. Now would be M1 divided by E instead of A will be I. And this one will be derivative of M1 and the rest should be the same, no? Okay. I can come here, control copy. Control V, I'm not sure if it's going to make it or not. All right, so line 16. Invalid expression, checks missing multiplication. Am I missing anything here? I think it's not understanding the 3 points, but
You're missing a plus sign. Between the second and the third term.
what am I missing? Oh, a plus sign, correct. So where do I need to put it? Before or after the 3 dot, you think?
Okay.
We're gonna find out. Okay, that's fine. Easy to do that one, no? Okay, so, all right, we could do now what? We could go back to the notes and say this is equal to this, no?
Well, we forgot to. We want to-
Oh. 1, 2, yeah, so. Thank you again. And 2, so run.
Also, S is 1, 2, 3.
Oh, it should be S2, this one. S2. See, thank you for checking all that stuff. So now maybe we have it correct. So this should be all the expression for R1Y. Maybe you can do it a bit better here. Let me do this. Simplify Q1 vertical. Okay, about it, okay. Okay, you see, that's the type I don't like about,
You can do pretty,
it's too pretty.
Yeah.
So pretty simplified,
just pretty.
and it will simplify as well.
I mean,
That's it.
Yeah.
Pretty. Q1D, but again, it's not that pretty anyway. Because you put it on lines, but it's not bad.
also if you use live script, it actually makes it kind of nice.
Ready? So can we go live script instead of that one now? Or?
Copy all that.
That doesn't look that bad, okay? So basically now you could come over here and just copy that expression. So let's see, you could come over here. All right, we could just write down over here. Q1V is equal to R1Y L divided by, I want to change the order, EA, I like it more, minus P bar plus R1X minus 21 RYL divided by 2 EI plus R1Y L cube over 3. PL cube divided by 3 EI. No, okay, it doesn't matter, but that's the deformation, the maximum deformation of a cantilever beam with the force being applied at the end. Okay, but you don't recognize it, it's fine. You're not supposed to recognize it. Okay. So now it's going to be very simple because we already have part of the code. Now we have this. Now, so with this, we did this for Q1 vertical. What is the other equation we need to do this for? The other question? Oh, maybe. Oh, here cube, yeah, it makes sense to have a cube. Yeah. All right. So we did this condition, no additional equation. We need to do now the other one. All right. So now we do exactly the same thing for Q1 horizontal equal to 0. So this time I want to go a little bit faster. Okay. So what are we gonna have? Q1 horizontal should be equal to what? What is the horizontal force being applied at 1? R1X, no? So it's the same thing with R1X. So the only thing I'm going to copy here is these two lines, okay? Where basically should be exactly the same thing, but what should be the only change? P1 over EA, partial of P1, what is the only change? Instead of R1Y, it's R1X, no? But everything else should be the same. PS1 plus partial P2 over EA partial P2 R1X PS2 plus integral of M1 over EI partial of M1 partial R1X DS1 plus partial of M2 over EI partial M2 partial R1X DS2. Okay, so if you want, let's do one more thing here and then we're just gonna go to the MATLAB. What should be those partial derivative terms? What should be partial of P1 with respect to R1X?
What is P1? 1. So this one should be 1, no? Okay. What should be the second one? Partial of P2 with respect to R1X would be 0. Okay. What will be partial M1 with respect to R1X? 0, no? It's in M1 is in partial of R11. I mean, I can be wrong, then I'm not copying anything. And now the last one with respect to R1X. So here's going to be a bit more complicated. It's going to be equal to what? Negative S2. Okay, so what is the magic to have MATLAB now? Copy and paste, no? We just need to change everything. So let me come over here. Here we go. So additional equation 1. So let's call maybe, yeah, sorry, maybe let's call this equation here. It doesn't matter. I mean, I do the change afterwards. Yeah, we can copy paste everything to the truth. Additional equation 2, which would be Q1 horizontal equal to 0. So let's see, let's call this one Q1 H. So what do I need to change? Only this one here becomes X, no? On the partial. So let me make sure that I don't make any mistake. Come on. X and X. Okay, so maybe we don't need to simplify, and maybe delete it. All right, and let's say this would be Q1H. Did run it, so now I don't know which one it is. Is it just the second one? Yeah, so, and this is what we get over here, no? All right, so you have it right there. We can just copy that equation. So that's good to use. All right, so we're gonna have here. Q1H is gonna be equal to what? 2 P bar plus 2R 1X minus 3 R 1Y divided by 6 EI L cube plus R1X times L divided by EA. Okay, so here we go. So now basically we have these two equations. What are the variables for these equations that supposedly are not given in the problem? Imagine that everything that you have over here, what is the problem? Okay, consider that in real life, you will, L will be known, P will be known, no? And the cross-section will be known, no? Okay, so really here, what are the two unknowns for these two equations? Will be R1X and R1Y. We have two equations, two unknowns, can we solve? Okay, so next step is 5. All right, so I mean, the real thing we could do, to tell you the truth, is that we have 5 equations, 5 unknowns, no? We could go and solve for everything. So, but to do this. So next, let's solve the system Q1 vertical equal to 0, Q1 horizontal equal to 0 for R1X and R1Y. I mean, we could solve the 5, but I think it's just going to complicate stuff. So now that we have the MATLAB code, let's see, how can we do that? Can I just go probably here to the code now? Yeah. So let's see, maybe let's call this one here equation 1. Let's call this one equation 2. And here I'm going to need again a little bit just your help a little bit. So let's say here solve Q1 vertical equal to 0 and Q1 horizontal equal to 0 for R1X and R1Y. Okay, so yeah, I don't remember how to do this, so I know it's solved. If we need to solve both of them, I know how to do it in Maple, I don't know how to do it in this.
You can equate equation 1, equation 2. And then
Huh? Okay, so
equation 1 and double equal.
yeah, so basically you say we could do maybe let's say an AQT will be equal to EQT1 minus EQT2. Is that what you're saying?
Equal. Instead of
Okay, but then we need to do this different, no?
you have to use double equal.
On which one? On the first one or second one?
Instead of the minus.
Okay. All right,
Yeah.
and now we just say solve EQT, but we need to put the variables, no? Comma,
R1.
okay. I'm probably gonna have to put a period, I don't know. Can I put something up front of the solve, like, yeah? Can I do this in front of the solve, or? I don't know if I can do that.
Yeah.
Yes.
Yes?
Yes.
I don't know, because,
Yes, for your second term, you have to put them in brackets inside the solve.
this one,
Yep, RX, R1X, and R1Y should be in brackets.
brackets, yeah, because, okay.
And that'll output your two variables.
Okay, so that should work, or?
Yeah.
Showing like some type of error here, but we'll find out. The error cannot be there. Oh, okay, yeah, why is giving, oh, because you cannot take a view as an equation, okay, I get it now. So maybe we did bad in it, so basically, all right, let's come over here and let's say EQT1 is Q1V. And equation 2 is Q1H, no? And that should work, okay. But still kind of showing some error there, we find out.
Just the caution that you know you have extra lines.
Yeah, but it cannot be 0.
Because the equation.
This one?
Yeah.
I need to equate that one to 0?
No. Q1B and Q1H. You have to equate those to 0 so that it's.
So in here you say?
No, well, we can do it there in the. Yeah, here. We go equal to 0.
Do you think that's gonna change something?
So. The way I did it inside of the solve. Instead of EQT. Just open brackets
Yeah,
and then Q1.
I think that's the problem. We need to put here probably brackets EQ. EQT1, EQT2, no? Is that what you're saying?
Yeah, I just did Q1V equals 0 and then Q1H equals 0
Okay, we can do that one. So Q1V
equals
0,
double equal.
okay, double equal, and Q2V,
Q1H.
oh yeah,
Or
so,
whatever.
no, you're Q1H, yeah,
Equals
Equal to
0, close bracket.
Yeah.
And that was all.
that makes more sense, even though I could be doing exactly the same thing, no, because, no. No, I understand. So still give problems there, but. Okay, we don't need this now anymore. All right, so now I gotta do pretty R1X. Do you think that will do it?
Yeah.
All right, so and pretty R1Y. So and then we can compare to the ones that are here, but I don't know, to do it differently. Yeah, they kind of look the same. Yeah, so there you go. So here what we can do now is. All right, so obviously I'm gonna put here solving with MATLAB. We got that R1X is equal to, so which one that was first? That's it. R1X is equal to minus, is it a minus? Okay, so minus P bar 7 A squared L to the 4th plus IA, plus 12, I would guess. IA L squared divided by 7 A squared L to the 4th plus AI plus 60 AI L squared plus 36 I squared R1Y equal to 18 P bar L squared AI, and the bottom should be the same. So I'm just going to copy the one that is on top. Okay, so now what is the magic? I mean, the magic, no, it is no magic. The good thing about having this stuff is that now that the axial forces P1 and P2 and bending moments
M1 and M2 are known in function, let's say, of P. So basically now what we have, if you remember from the, what is that page here? The summary. Summary, we have P1 equal to R1X, no? What is R1X now? We know R1X in function of P, no? Everything is done. R P2 was R1Y. We know R1Y. And same thing for the M1, M2, no? Now all P1, P2, M1, M2 are known. Okay. Now that the actual forces P1 and P2 are then the moments M1 and 2 are known in function of P. D horizontal deformation at point 2 can be determined as follows. So basically, using exactly the same thing. So what should be Q2 horizontal? Q2 horizontal should be equal to what? I mean, we put at the beginning, that should be equal to what? Partial of U with respect to of what? Horizontal. Remember, you need to apply, you need to take the derivative of the strain energy with respect to the force on the direction acting at the same point. No? So it will be in function of P bar. So basically, what are we going to have? If you write it down, we're going to have exactly the same equation that we just wrote like twice, no? The same as this equation. But what do we need to replace? The R1X by P bar, no? Yeah. Good thing is that it's only copy paste on MATLAB, no? All right. Let's write it down. So this will give us what? Integral of P1 over EA partial P1 partial P bar ds1 plus integral of P2 over EA partial of P2 with respect to P bar ds2 plus integral of M1 over EI partial M1 over partial P bar ds1 plus partial of M2 over EI partial M2 over partial P bar ds2. Oops, sorry guys. I've run out of paper here, so here we go. Okay, as you do this, I'm going to come here to the MATLAB code, where basically I can just say the horizontal deformation at point 2 is, and then can just copy either one of these ones. Control copy, Control V. So Q2 horizontal, let's say, which is the one we need. What do I need to change over here? The R1X by P bar.
Okay, so. I click on this one. Is it all this stuff? Looks like no. Wow, it's only the last one, no? Let me double check. Let's maybe put over here. Solution. Yeah, okay, good. So it's not complicated at all. So at the end, what we have, Q2H will be equal to 2P bar. Oh, no, here's the problem. Okay, it did not do it the way it should have done it. So we're going to, so why is not replacing R1X by the values?
Yeah, once you,
I need to do a copy paste, you think I need to redefine it or?
well, once you solve Q2H, you need to use subs.
Okay, so you will say I use here, what can I say here, like P1? All right, the quick way to do this will be to do what? Hold on 1 second. And let me do it quick because we don't have time. I'm sure this is a more elegant way. These are the two expressions, no? Yeah. This is the expression. So why it's not doing it? I understand why it's not doing it, but it doesn't matter. Let's do it this way. I guess I could define it that way, no? And R2X or R1Y would be this one. Copy. Okay, let's see.
That's what I got for the
Yeah, but it should.
Q1H.
Yeah, but this one should be in function of P, not R1X. Should replace the R1X by all this. You see what I mean?
Right, you gotta use subs at the end.
But why is no one gonna do it? Because I think I might have to redefine those variables. See? P1, P2, I might have to redefine the variables. Okay, I think I know. Yeah, you can use the subs, or I think we can do this. Maybe the other ones were not needed. Maybe these were not needed, but I'm just gonna comment them, see if that works or not. Yeah, so you see how beautiful is the solution, no? But it should not be that bad. You know, have it here.
You have to simplify it.
Yeah, so pretty simplify Q2H. Yeah, because it's not bad. I have here one solution is not that bad. There we go. It's not that bad. Huh? So at the end, that will be the solution. So it's not a 2P, but basically will be. So will be. Yeah, so will be. Okay, I'm just gonna write what I have here. P bar L2 over 7 AL squared plus 12I divided by E times
7 a square L to the fourth plus AI L square. I should have put 60, so forget about, I forgot to put the 60, so I put it now, plus 36 I square. Okay, guys, so you see that. Instead of when you have to do a problem completing, think about when people have to do this without computers. Okay, and then you won't feel that bad, no? Yeah. With computers, you see the last steps were pretty easy, no? If you had to do all that stuff by hand. Any questions? So basically, probably tomorrow I'll come back to this problem. We put some values and we can go and check with CMAP, no? Okay. And then we move into another. Okay. Every problem we got to set on our way, no? All right. If you have any questions, see you tomorrow.